We are thrilled to have such an enthusiastic and diverse group of participants for joining us in this wonderful journey. For those who want to know about me, who I am, and I am Ruth, the lead technical liaison for the skilling programs at Art Park ISC. I'm here to ensure everything runs smoothly, and then take if you have any queries or any concerns at any point, please don't hesitate. Just drop me an email, so I'll be there to help you out. Okay. To formally commence this program, it is my privilege to invite Sheila Prabhakar, the program head of the Center of Excellence, Wired and Wireless Technology. She has been the guiding force in shaping this initiative, and we are honored to have her here to share her insight. And officially, we can now begin the course. She'll now, talk about a brief of about Art Park and the CoE and her initiatives.
Hello, everybody. Good afternoon, and a very warm welcome to this tutorials, which is being organized by Art Park. We thought I'll take few minutes for the first timers to give a very quick introduction about Art Park and what we do in the Center of Excellence here for wired and wireless technologies. So let me just project the files that I have.
Yes, ma'am, it's visible.
Yes, thank you, Ruth. See, Art Park is an incubation hub for robotics and AI. So when you get a chance to visit Art Park, I think 3 weeks from now, when there are online sessions are over and the practical sessions start, you will see multiple startups in the area of AI and robotics housed in our facility here. So our Art in Art Park stands for AI and Robotics Technology Park. And Art Park is promoted by Indian Institute of Science, and we are seed funded by DST, Department of Science and Technology, and GOK, which is Government of Karnataka. It is a Section 8 non-profit company promoted by Indian Institute of Science. Now, about the Wired and Wireless Technology CoE, this is a program within Art Park, and the charter for the CoE is to promote innovative market-ready solutions. And WWT CoE, again, funded by Government of Karnataka. And how we promote market-ready innovative solutions? Mainly working with innovators and startups. We are about 8 to 9 months old now. We have been working with multiple innovators and startups who actually build the solutions which are ready for the market. And to in about the technology that is available with them. All this helps our startups to build the innovative products. Okay. This is brief about our Center of Excellence. Now, a very quick look at the 5G lab facilities that we have here. I noticed that many of the participants for this workshop are from universities. There are faculty members, and then there are students. Many of you may know about the Bharat 5G use case lab. There are 100 such use case labs set up across various universities in India. This is the block diagram of the Bharat 5G use case lab. Okay, and as you can see, we have it is configured as a private 5G network along with various 5G user equipment or accessories using which multiple use cases can be built and demonstrated here. This block diagram is about the parallel setup that we have. The G node Bs are the radio portion of the private 5G, which are commercial. And then on the core side, we have a
recording in progress
commercial code as well as the open source core software. And then the complete infrastructure, including the network switch, the USRP lab radios, etc. A lot of experimentation can be done here, and startups and SMEs who are developing technology for the 5G can use test bed for testing their solution not only for testing, but verification, interoperability testing with other subsystems, etc. This is more detailed spec about the radio that is available, the media edge compute server that is available in our setup. And also, since I mentioned we have various options on the core, a commercial core as well as open 5G is a comparison of what the commercial core offers versus what the open 5G offers. Don't worry, again, if you see a lot of text here at the end of the course, you will be able to understand everything that is here on this slide. More details about the media edge compute here. I think that session you will get a chance to interact with the experts and get to understand more about what the MEC servers do in the setup that we have. This is a layout view of the Art Garage facility of ArtPack, where our lab is set up. And we have multiple radios which cater to both, which cover both the indoor area as well as the outdoor area. An attempt is done in this slide to show the area covered by each of the radios. The green boxes are the multiple radios that are located at different places, and then the arcs that you see here show the radio coverage of our facility area. So outdoor provision we have for carrying out tests with respect to drones, etc. On this part of the building as well as on this part of the building. Okay, even here it is just not shown, that's all. Okay. Then other facilities that are available in the use case lab, apart from 5G enabled drones, we have UGVs, that is unmanned ground vehicles, which are used for Industry 5.0 use case testing, and also factory digital twin. All these UGVs, which are 5G enabled, are part of the setup, which demonstrates use cases related to Industry 5.0 and factory digital twin. And there are infrastructure cameras. These are all 5G enabled, which stream the video. Apart from the lab facilities, we have multiple innovation and research programs anchored in the CoE, the list of which is you see here on the slide. The first few are all sponsored by us, and they are being executed in different research institutes, as you see, IIIT Dharwad, Indian Institute of Science, MIT Bangalore, RVCE. These are the programs we picked up for financial year 24-25, and for 25-26 we will be working with more innovators and researchers for more of these programs. And on the bottom of the slides, you will see some of the programs which are being executed in-house. One major one is related to multi-drone innovation cluster. The other one, as I had mentioned, related to the Industry 5.0. Just a glimpse of the partners who are involved in the multi-drone cluster innovation program. We have multiple drone companies which have developed 5G enabled drones, and then we have a few startups which are interested in the area of narrowband IoT, and also taking the private 5G network for some of the applications like disaster management, etc. Then Bixby is a company which develops the radio portion in the 5G network, and they will also be contributing for the design of what we call as network in a box. And the Niral is our partner. They are not only helping us in providing the Niral OS, which is the 5G core, but also helping us in the skilling program. In the coming days of this workshop itself, we will have many experts from Niral who will be giving the technical talks. Even today's talk is by the expert from Niral. This is just my of the one of the internal programs that we do. I'll stop my brief presentation here. I would like to thank our collaborating partners, Niral Networks and Proyava, who have joined us in offering this workshop. And this is the brief introduction. Thank you very much, Ruth.
Thank you, ma'am. Thank you. Thank you, ma'am, for your inspiring words, and also you have shared what are the assets of Art Park and COE, and also for setting the stage for this exciting journey. Moving ahead, it is my pleasure to introduce Dr. Sanjeev Srivastava. He is the skilling director. He will now introduce today's speaker to the participants.
Thank you. Thank you very much for giving this opportunity to introduce the speaker. And again, I would like to welcome you all on behalf of ISC, Art Park, Government of Karnataka, Government of India, everyone, because of all these agencies and these institutions, we are here to start the journey in 5G community and trying to make this kind of community in a bigger way so that people who will be part of that will strengthen their knowledge, their expertise, and they will interact and have really good networking of ISC, Art Park, speakers, and other people who are participating. So we are trying to create really a good 5G community. And today is really a great occasion. Today Sivaratri is there. And first of all, I wish you again happy Sivaratri. So I would like to introduce our speaker who is very much part of this journey and through this company as a neural network, as Ms. Sheila has mentioned. So Mr. Sivaramakrishnan will be the first speaker to start this journey, and we say generally Siva. He is known as Siva in his organization, and he is a seasoned technologist and a strategic professional with remarkable career spanning over 25 years. He has played many important roles in technology implementation, deployment, notably in groundbreaking projects such as 4G WiMAX. Throughout his career, he has effectively leveraged IT to enhance operational efficiency and drive bottom line growth, particularly evident in his tenure like post media. He is having the bachelor degree in computer science as well as the master degree in management, and he is serving for last 25 years. Currently, his position is at Niral Network like customer success program lead, and his area of interest includes private 5G deployment, training to deployment to specific feature rollout. He is also very much looking for the future 5G advance and 6G solution development. With this, I would like to request Sivaram Krishnanji. First of all, I would like to thank for giving time to be part of this. And also, I would like to thank all the audience who has come all the way to join this course from their busy schedule. So I would like to hand over now the stage to Sivaram Krishnaji to take over and start the journey of today's 5G course. Thank you. Thank you very much.
So thank you very much, Ms. Sheila, Ms. Sanjeev. So it is a great opportunity for us to be part of this journey. And as Mr. Sanjeev told, I'm from Niral Networks. At Niral Networks, I take care of customer success program and the related technology. So today we will be starting an introduction, and in this introduction we will be mainly focused on 5G, but we will touch upon the 4G topic so that our understanding is more progressive to what is the technology that is getting rolled out. So at Niral, we have been quite active in the last 5-6 years in first developing a solution around 5G. And to this date, we have about 60 plus deployment of private 5G solution. So we are a very few company in India who has the expertise in rolling out private 5G. We have done so for in the power grid sector and in the coal mine in India. And we have done an extensive rollout of 5G use case lab for about 50 premier engineering colleges and other institutions in India. So this is what you see on the slides is a typical architectural block diagram of 4G. So be it 4G or 5G, see, a lot of us have an experience of using them. Is that there is a mobile that was there in 4G, which was predominantly the case, but that focus is shifting out, and then 5G is trying to play an all-encompassing role to bring in more devices, into the entire communication ecosystem. So typically when, let's take 4G, and then if we have to connect a mobile to our base station and the complete backend infrastructure, typically if I can put it in an abstract way, basically the system, that is the backend system, starting from the right of E node B, what is highlighted here, to the serving gateway, the MMEs, the PDN gateway, uh, basically is interested to get information from the mobile as to what are all the basic configuration. The basic configuration involves the IMSI number, and then the related parameters, and then validating that in the system is a proper configured subscribed SIM is trying to connect. And once this authentication is done, then we go ahead to establish the different bearer paths within the system, starting from E node B into the PDN gateway, and then making sure the mobile is able to comfortably communicate based on the QoS parameters it is entitled to, or it is subscribed for. So typically, as you see in the system, the different components in this 4G ecosystem are E node B. So E node B is typically what you see on any of these cell towers, and then they help in receiving the signal, radio signal, and then converting them into a proper control or data packets to further the protocol stacks that are present there, and then communicating to the backend, which is comprising of MME, the serving gateway, and the PDN gateway. So typically, these infrastructure equipments or components together facilitate both the control path and the user path communication. So typically, a control path communication will do the authentication of the UE, and once the authentication is successful, the backend infrastructure will facilitate to create the bearer path through the system, that is starting from E node B till the PDN gateway, and then facilitate the communication as per the QoS prescribed at the time of subscription. So these are the two main activities at a very abstract level the system performs. So if we take what you see, all the orange indicators or the orange flow, basically that path handles all the signaling flow or the control flow. So when UE connects, first the UE need to be authenticated, and once as part of the authentication, it will check with the database which is highlighted by HSS, and in terms of whether the configuration are proper. And then once you basically get the authentication through, there is a green signal given for the bearer paths to be established. Sorry, I told the orange as the control path, the blue is the control path. And the orange indicates the bearer path establishment. So right from the eNode B, you need to have a bearer path established to the PDN gateway so that the traffic can be properly routed to the PDN, that is the data network, and the communication can take place with the various other IP network components into the cloud. So here, a couple of aspects are there which we need to be highlighted. What you see are all the different interfaces that are highlighted. So basically, these interfaces such as S1 MME or S11 or the diameter communication are basically handling the control path, authenticating the SIM. So when an eNode detects a UE is getting attached, it forwards to MME. The MME gets a lot of information from the SIM that is configured on the UE, pass that on to HSS, and then all the validation is done for the configuration. Once this is through, we have the GTP tunnels that are created to facilitate the bearer path between the eNode B to the PDN gateway, so that all the data packets which are at a different protocol at between the different components, finally, when they are routed out of the PDN gateway, they are all IP packets. So this is how a typical 4G backend network functions and facilitate the control path and user path communication to go through starting from the eNode B till the backend. So on the right hand side, we have indicated a similar communication flow on the 5G side. So similarly, these functionalities of say a user path, control path are all taken care, and then they are used in a similar form in the 5G as well, barring a lot of improvements that has been facilitated in the 5G, which will incrementally know exactly what are those improvements. And basically, the crux of that is that the same control path and user path aspects, where the control path takes care of authentication and the user path taking care of bearer establishment, happens in a very similar abstract way on both 4G and the 5G network. So this is a flow representation of whatever I told previously. So the first aspect is UE is trying to attach, and once a UE is trying to attach the MME, which takes care of mobility and authentication aspect, retrieves all the SIM information from the UE, and then it basically does a process of authentication and security check. So for that, it takes the information that is stored in the HSS. And then once this authentication is through, various location updates, other things are done that we need not go at this point in time. Once the authentication is done, then it is the question of creating the session. So what I mentioned about the bearer establishment, making sure that at eNode B, at serving gateway, at PDN gateway, there are enough and required the bearer establishment, be it a GTP tunnel or making sure the IP packets are passed end to end, is all taken care. And that is what we refer to as the bearer path establishment. Once these bearer path is established, and UE is comfortable to do all the operations, say like you connect to the eNode B and then you want to browse a YouTube video. So at this point in time, after bearer path is established, it is all good to go. And then any of the data sessions can pass through seamlessly between UE and the backend infrastructure. And various other features, such as if you are making a call, say you are dialing a number from the mobile keypad. At that time, various additional bearers are created, and or an existing bearer's characteristic is being modified with respect to QoS or with respect to speed, etc. So those are also the other handshake that happens in the backend system to facilitate the call flow. So similarly, what you see on the top right-hand side, the same functionality of the authentication and bearer path establishment is also taken care in the 5G architectural level using various components. And this we will see into more details as we go forward. So before we dive into the 5G, let us look at a couple of concepts. So I'm not going to go into any great detail here, but I want to highlight or alert you. So these are some of the concepts you can start going through in greater details for your better understanding of 5G system architecture, or tomorrow if you want to develop any of the subcomponents or features in the system. The first one is the OFDM. So basically, starting from 4G, the key concept, technology concept that was added is the OFDM. So for example, if you are sending a packet of a video on your WhatsApp, right? This is a big chunk of data that is going to be transmitted from an application to an application, going through an IP backend. But much below that, in terms at various control data and further at your digital signal processing, how these bigger chunk of data are handled
Recording stopped. Recording in progress.
are with respect to breaking those bit string into smaller chunk of data, and say at an OFDM symbol level, it is about 15 kilohertz of data. And in those 15 kilohertz of data, you apply your modulation, and these modulated packets are pushed through the carrier from the transmitter to the receiver. So here the view of representation is given. So on the right hand side, you can see at a frequency level, if you see how these individual subcarrier data are pushed or given. So the F0, F1, F2, F3 are the different frequency. So you can see each of the subcarrier data of 15 kilohertz is getting pushed in each of the subcarrier at a frequency level. But on the left-hand side, you can see at a time scale level how these different frequencies are represented. So basically, the OFDM helps in basically handling a bigger chunk of data, how they are at a individual frequency level, broken into smaller segment, and each of these segment how they are orthogonally varying signal in terms of your phase. Everything is handled, and so that when a big chunk of, say, when we say in N78 band, you're having a bandwidth of 100 megahertz. And these 100 megahertz are broken down into different subcarriers. And these subcarriers are orthogonally spaced. And then they help in achieving a better data rate, taking into the consideration that when you push data in this 100 megahertz bandwidth, you may have various different scenarios to handle of multipath, etc. So OFDM is a technique that is used to have an efficiency of handling the data at this 10 megahertz bandwidth level. So this is a subject you can start studying about, and you can start having a better understanding of it. So the next aspect is the MIMO. So the MIMO, in a very abstract level, can be understood by this diagram where you have multiple antennas that are there at the transmit, and you have multiple antennas that are there on the receive side. And MIMO is a technique where how efficiently you can push these data from the transmitter and receive it, spanning across multiple antennas, so that you can effectively utilize the different channel characteristic and achieve the best data rate. So this MIMO has different techniques such as pre-coding or spatial multiplexing. So it all depends on, say, when you are pushing a data from a transmit side, say you have 4 antennas, then how are you going to split the data? Are you going to push the same data across all the n number of antennas, or are you going to split those data across those n number of antennas, so that you have a better understanding on the receive side as to how the data are going to come? Say, when we talk about this multiple antennas, right? Because when you push the data on the air, so it is not sure that it will have lot of propagation delay. It will have lot of interference, by which the same data will be received on the receive side multiple times, because one data is directly going, but another data is getting reflected from a building, right? So in the pre-coding and spatial multiplexing, they are the technique where you have some information about the channel characteristics. Say, when you push the data from one antenna, then it has so much of delays, or it has so much of noise. Some knowledge if you have, then it is easy for at the receive side to reassemble all the packets, because the same, assume that in a pre-coding you push the same data across multiple antennas, you should have an fair amount of channel characteristic information on the receive side, so that from first antenna it might come at this much delay, and on the second antenna it will come at a different error rate, so that I can use a particular algorithm to make sure across all the received packet how I can get the best data on the receive side. So these are the different aspects, and there are some scenarios such as the diversity coding where you don't have that much of information on the channel characteristics. And there, how do you basically encode each of the data through each of the antenna, and then receive it on the receiver side, and then use different algorithms to basically recreate a good chunk of data, so that it is good on throughput, it is better on error handling, etc. So OFDM and MIMO are two concepts which are very effectively used from 4G. Nowadays, a lot of Wi-Fi implementations are also having this. So that how you can use your radio frequency channel, and then how effectively you can achieve a greater throughput, and how you can minimize the error report, so that the error correction are applied at as minimal level as possible. So these are the two topics I think you can start studying about. The idea was not to go into much detail, but to just highlight some of the concepts that are common across from 4G to 5G and maybe going forward also, so that in your various subcomponent development, it can be of much better use. So what we will do is that we will cover this the 5G architecture, and then probably after that we will take up some questions if you all have. As we explained, this is the architectural block diagram of 5G. So as explained, this there is a distinct demarcation of the control plane and the user plane. And the various interfaces are all highlighted here. So if we leave out for a moment, so this is basically highlighting more on the 5G core, and then showing all the other components in the 5G, such as a 5G UE or a G Node B or a RAN as a individual blocks. So typically, when an 5G UE tries to connect to a G Node B or a RAN, it basically connects and does a control path negotiation. And in 5G, as part of the core, there is a set of network function that handles all the different functionality, be it in control path or as well as in the user plane path. So once a UE tries to connect, from a control path aspect, the interfaces defined are N1 and N2 interfaces, and between the G Node B and the AMF network functions. So what you see on the top, the different small block diagram in the control path, are the network functions. So in 5G, there is a set of network function which does all the specific functionalities, be it on the control path or on the data path. So when it comes to the control path handling, the AMF handles the access and mobility function. It handles all the control communication, basically on the N2's interface. And then basically it will all start with an UE trying to attach. So AMF, once it detects and UE attach, it will do all the basic authentication. It will check whether the RAN it is coming from a authorized RAN, and then whether all the other aspect of the UE mobile are proper, such as the IMSI value or the PLMN ID. So the PLMN ID is a network ID, say like a Geo or an Airtel or a BSNL. They'll all have an individual PLMN ID. So once all those basic authentication are checked, then you go to the level of doing an authentication on the UE. So as a first step, the AMF will identify the UE, for which the AMF will send communication to G node B and then to the UE. So there are between the AMF and the G node B, there are two aspects of communication. One is N2 and one is N1. N2 is basically all communication to G node B. N1, which the N2 is normally referred to as N gap layer, and N1 is the NAS layer. So the direct communication to the mobile is handled through the N1 interface. So basically what G node B will do is all NAS messages, once it received, it will just forward it to the UEs. So through the NAS message, it will go and check what is configured in the SIM with respect to all parameters. Say it will check whether IMSI values, PLMN ID, and there are other parameters like SUKI, the identification of the UE in terms of an identified number. So those details are extracted, and AMF will use a set of network functions such as AUSF, UDM, UDR to authenticate whether the IMSI value that I received is already configured in the system. This UDM, UDR are the user data management and user data registry. Those are typically, you can assume as database. They are populated through a backend controller function, where typically it will be URL-based application through which you will configure a set of SIM into the system. So basically, what is received from the SIM and what is configured in the system is verified. And then once this level of verification is done, then there are other details such as the ciphering and other algorithms that are configured on the UE is also verified with the authentication keys and the operator keys that are configured as part of the user management system. So together, these two set of authentication are the major part of the authentication setup in the control path. Once this phase is done, the AMF will take care, will communicate with the SMF, the session management. Say once the authentication is done, you have to go ahead and establish the bearer path. So to facilitate that, AMF will take the help of SMF, Session Management Network Function. The Session Management Network Function in turns takes the help of other network functions such as PCF, where all the policy parameters are configured. Say in 5G, similar to 4G, which is a little more extended, the QoS, quality of service, is configured on a per subscriber basis. So similar how the IMSI values are derived from UDM, UDR, the PCF will also go ahead and extract lot of policy details. The policy data will be something like QoS. What is the priority? Say a voice call will be given a more priority than an internet browsing. So all those priorities are defined within UDR and they are extracted by the PCF function. And SMF basically decides whether all these parameters are same as what is configured to what is getting received from the mobile. And the SMF gives appropriate direction to another network function called as UPF, user plane function. And basically, the user plane function is where all the bearers are created in the 5G code. Of course, the control path verifies, checks all detail, but the final bearers are created at the UPF. So by bearers, what I mean is that you have an indication of an interface N3 and N6. So N3 is an interface between the RAN and the 5G core user plane function. So at the N3 interface level, for every subscriber or every 5G UE, it might be a mobile, it might be a CPE, it might be an IoT device. Irrespective of that, a tunnel is established between the RAN and the UPF. And all communication of the subscriber will happen through that tunnel for every subscriber. And so at one side, we have an N3 interface that handles all the tunnel, and the data is brought to the UPF. And from the UPF, depending upon the DNN that are configured, these are routed to various IP interfaces that are indicated by N6. So here, when I say different interfaces, different DN, it can be that in 5G ecosystem we'll see little later that there is a concept of local cloud. To the core, you can build a local cloud, and there is another public cloud, say an AWS or your email server or any of those public cloud component. So at the UPF level, various user plane DN specific interfaces are created so that the data traffic gets routed through the respective DN. So typically, when you are doing various type of activities, say you are doing a voice call, and from your mobile you are also browsing an internet. So the data from your Gnode B or RAN, that is, the mobile is connected to a towers, the equipment. From there, it goes to the 5G core, and in the 5G core, it goes through the UPF. So any of the uplink data will go from N3 interface to N6 interface, and any of the downlink data will come from the N6 interface to the N3 interface. So this is how once you are authenticated, the bearers are created at the user plane component of 5G core, and the end-to-end bearer communication is facilitated from your mobile to your RAN or Gnode B, going through the 5G core to the respective cloud. So this in a nutshell is what a control path and a user path communication that is facilitated from mobile to the radio access network to the 5G core and to the cloud. So this is how the end-to-end communication that flows back and forth in the 5G system. So this is at an architecture level. So we will, going forward, we will see from various perspectives. Say we will see from a deployment perspective, and we will see from a use case perspective. So the same concept what I explained now, you will be able to grasp it better as we go through those explanations. So I'll stop here for a moment, and I would entertain some questions as to your understanding or all other aspects of 5G architecture.
Yeah. Hello, sir. Good afternoon. Thanks for that insight on 4G and 5G. So my question is, like, we are at a stage wherein we are in the phase 3 of deployment of 5G, where we are seeing like the EMBB URLCC being there in phase 1 and 2, and now we are in the 5G advanced. So, what is your thought process on the integrating the new uh, in the coming technologies or the advanced technologies 5G? How we can integrate the candidate modulation techniques like FBMC or OTFS, those kinds of modulation techniques rather than the regular OFDM or its variants of OFDM as such.
Okay. So I think it's quite an advanced question at this stage. But nevertheless, in all the deployments that we are having, by deployments, I even mean the deployments that are happening with Geo, Airtel, BSNL, or the 5G use case lab. What has been to a great extent achieved is the EMBB, right? Because when you roll out a technology, its effectiveness is realized if an end-to-end application ecosystem or application equipment infrastructure is available. So I think that is what has been achieved. Even if we go to URLLC, the end-to-end deployment at when I say end-to-end deployment, I'm seeing what from an R&D can be taken till then end user deployment level. Even URLLC deployments are not at to even to a beginning extent being tried, right? So I think the points on modulation, what you are indicating, are all onto the 5G advanced level and 6G. So I would say we'll have to wait and watch on the complete ecosystem to evolve uh, much beyond the R&D lab, where it can go into some of the application level use case for it to. So maybe like, I don't know the exact timeline, but at least we are 3-4 years ahead of an operator deploying 5G advanced, right? So probably at that level, some rollout might happen.
Okay. Thank you, sir. Thank you. Sir, I have like one more short question. Can I take it, ma'am?
Yeah, please.
Sir, like we have like in 4G, we had like LDA, LTM, and NB-IoT. So, how does this coexistence of NB-IoT come into picture in 5G? And is there any relevance on development of NB-IoT and the development of RedCap? Of course, with both.
Please, if you can refer, I can answer with respect to NB-IoT. At a development level, integrating use cases on IoT, at a product level also, I would say a lot of equipments are today capable of supporting NB-IoT. And that I think might quite soon happen. But I don't know at this stage on the red cap what would be the timelines that will be feasible.
That is in release 17. Yes, sir. Thank
So
you, sir.
typically, if you see product wise, right, what is very comfortably there in the market are release 15 and 16, right? Right. I'm not telling, maybe in some cases 16, 17 are there. So as a product deployment wise, that is where we are, right?
Thank you, sir. Thanks for that insight.
Good afternoon, sir.
Good afternoon.
Yeah, I'm Professor Pralay from Gopinath Pralay from Sri Sri University, Cuttack, Odisha.
Okay.
So I was listening your talk. It was very mind blowing, really interesting. So I have a small query. So can we include I mean say protocol, I mean say computing method related to quantum computing in 5G system?
The way I will try and explain in a very short possible way.
Sure.
In further slide, there are introduction about the edge cloud. So edge cloud is an architectural component where computing can be integrated into the 5G ecosystem. So anything around the direction of quantum computing and all, we will sort of coexist with the speed and latency that the 5G backbone will offer.
Sure.
So any development around there, I think if you follow on the multi-edge cloud or the edge cloud platforms that are coming forward, are coming into the market, I think that will be a starting point where all these quantum computing all can be rolled out.
Okay.
And there is a question in the architectural diagram why N1 is a dotted line, others are shouldered. Okay. N1 is more like an, see, that's what I told, right? The N1 at a physical level goes through the G node B, and all the N1 packets are forwarded from G node B to the mobile. So probably that was the reason why it was shown as a dotted line. So I think roughly we are following, we are good on time. So in the next 1 hour, we will separate it into 3 components. One is, okay, we talked about the technology, right? One aspect is we will give you an introduction to equipments that are available in the market, because finally all this technology should work on some equipments, right? That is one aspect. Then another aspect is we'll give an introduction about the edge cloud. And the third is we will cover some deployment scenarios. And the fourth is we will cover some use cases, right? So all these different perspective will help you people to understand the same concept. It will reiterate your understanding basically. Okay. So this is a typical implementation how a private 5G is implemented. So if you see on the system, there are about 3 servers and a firewall router, right? So one server let's take from the left-hand side. It is the RAN. So basically the RAN is the unit you will typically find in a cell tower. So it has a radio unit, and it has also some control and data processing unit. Then another equipment, what you see in the middle, it is a private 5G core server. See, because why we are telling server is that today all these have become quite prevalent, that a standard off-the-shelf COT server is being used to deploy any of these major software components. And similarly, the third one is an MEC server. So I was mentioning about an edge cloud, right? So to deploy an edge cloud, we have a separate set of server. And then we have a firewall router. Basically, it is more like a private 5G concept where you have a 5G network, and then basically using the firewall router, you put the content of the 5G network to a cloud and back and forth. So that is how the firewall router is represented. So coming to the RAN, so it typically does all the radio communication. It helps the UEs connect. Then once the UEs are connected, it will facilitate the connection using the control path. Then it facilitates a connection on the user plane through the data path. And so between the RAN and the core, you have the control path and the data path communication. So we saw the various network function. The other key thing what I want to highlight here is you would have seen lot of mention whenever a 5G ecosystem is mentioned, you also hear the term virtualization. So virtualization is a new concept which is there in the computing world for the last 10 years, where the world of Docker, Kubernetes, you can basically do an orchestration of the applications that you are going to run on a server. Depending upon traffic, if you want more instance or more containers to be spawned, you do that through this orchestration layer. So in 5G also mandates and I would say a virtualization environment where we have controllers that pretty much spawns different virtual machine. And typically in a standard installation, you will see a 5G core implemented as a virtual machine. Then if an IMS feature is there, even IMS feature gets rolled out as a virtual machine. And these virtual machines are controlled by is based out on an hypervisor, which is installed on the server. And so that is how the entire control path and data path of the core 5G core is implemented. And on the right hand side, what you see is an edge cloud. This is another architectural component mandated by 5G architecture. Basically, to see 5G offers you the speed, and that speed, if you want to really leverage and use an application server, say you have a drone that is connected through a 5G SIM, and then you want to do an analytics on all the videos captured from the drone. What you would want is that you would want to reduce the latency of the video packets that are captured at the drone and analyzed at the computing. So what you want is, if you have a local computing along with the core and the RAN, then the entire end-to-end latency and high availability becomes guaranteed. So that was the crux of introducing this edge cloud and then placing it quite local to a 5G infrastructure ecosystem. So here again, the way things are implemented is that, again, you have an hypervisor, and then the hypervisor facilitates spawning multiple VMs, and each of the VM you can run a drone analytic application or a video streaming server application, or any application where you want to leverage the latency and the local or high availability of a server application. We can do so leveraging the edge cloud. So edge cloud is nothing but a locally available cloud, similar to your AWS cloud or a Google cloud. And then as we saw in the user plane, depending upon the application, you can choose a DNN. A DNN can be an local edge cloud, can be a DNN. Then the second is that your access to internet through an AWS cloud can be one of the DNN. So that depending upon the application, you choose the DNN, the packets get forwarded at the IP level. So this is how a 5G technology, in terms of the available equipment in the market, we do the implementation. And this slide gives you an overview of how in a private 5G, you set up in your university a private 5G, or when you see come for the classroom session, you will see in Art Park. you have a system where you have a RAN, you have a core, and you have an MVC server. And this diagram illustrates how the uplink and downlink flow is facilitated going through the firewall router. So here, all the equipments are connected to firewall router. So the control path or data path from the RAN gets routed to the firewall router. And if it is a control packet, it will go to the server that is having a 5G core. And if it is a data packet, assume that data is going from a drone application. It will go to the 5G core. At the UPF level, the packets might be routed to a local MVC server application. So again, it will come through the firewall router and get routed to the application specific VM. So this is how the uplink and downlink transfer of data happens. These slides we will come back in the next session. Before that, we will have a look at the edge cloud. So I was referring to the local availability, having low latency and always available application to leverage the data coming at a high speed of 1 Gbps from the mobile device to the RAN and to the 5G core, and it gets delivered to any local application. So in the 5G ecosystem, edge cloud is an architectural component that is being suggested to be built, where you can have a local cloud infrastructure that you build using a hypervisor, VM, or Kubernetes, depending upon your implementation. And you give local computing infrastructure for the application to be installed, and used in an end-to-end manner. So typically, a lot of products are there available in the market which address this particular application need. Niral also has a solution which we are deploying in all our private 5G deployment, and we have also deployed that in an extensive way as part of the 5G use case lab that has been rolled out through DOT. So when we talk about the edge cloud, this is how it coexists in a 5G network ecosystem. So on the left-hand side, it is nothing but the control path and the user plane architectural component. In addition to that, we have a 5G UE and a RAN in the diagram. And on the right-hand side is the edge cloud. And we can see how, from an architecture point of view, it interfaces with the 5G core. By 5G core, I mean 5G core plus RAN. So here, if you see, focus on the bottom, you see a data path that can be established between a mobile to RAN, to the user plane part of 5G core, and to the edge cloud. So in the edge cloud, you can have a lot of VM. Say from your mobile, you are accessing a YouTube. Then the packets will not be landing on the edge cloud, whereas through the UPF, it will take another DNN and be routed to the public cloud. Assume that from this 5G mobile, you are accessing a facial recognition application, and the facial recognition application is there on one of the edge cloud VM. So whenever an image is captured, this image needs to get connected through an API that is exposed from the facial recognition application. So in that case, the application will communicate from the mobile to RAN to UPF, and the N6 interface here will point to the edge cloud, where to the specific VM in which the facial recognition application is there. So this is how edge cloud will coexist with the 5G architecture, specifically the 5G core, and it basically facilitates the end-to-end communication, leveraging the latency and the high availability aspect that are sort of achieved by the local edge availability. So, do you have any questions so far in terms of edge cloud? Else, we can move to some deployment scenarios so that you will have a better understanding of how a private 5G or a 5G from an end-to-end perspective or an application perspective is used. So typically, you would be wondering, right? There was a phone in 3G about 10 years back. You had a phone. You used to dial some numbers in that. But once you dial a number, the mobile phone will just capture that and forward to a circuit switched application where the typical MPLS way of getting this packet into a older back-end trunk exchanges or digital exchanges. But that changed a lot from 4G. So in a 4G, the concept of IMS was integrated into the 4G backend EPS, right? What they call it as an enhanced packet core. So what happened there was all your punches of dialing a number was captured by a SIP signaling, and the SIP signaling routed those packets to a software component called as an IMS. And what this IMS does, or similar to the control path and the user path on what we saw on 4G, 5G, IMS also has a control path where it interfaces to an external entity, which can be another IMS, and then route the call there, and additionally have a bearer path through an RTP channel to handle the SIP RTP packets and route the call there. Say, for example, whatever scenario I explained, in a 4G, you're dialing your friend. You are on a Geo network and your friend is on an Airtel network. So a 4G Geo network will originate the call, contact the IMS that is connected to the Geo 4G infrastructure, and then handle the SIP signaling and RTP signaling. Forward, this IMS will communicate to an IMS that it is existing in an Airtel 4G infrastructure, route the control and data packet there, and then that IMS will, through the Airtel 4G infrastructure, route the call to a specific mobile phone that is there on the Airtel network. So this is how the call used to happen. It will originate from a 4G infrastructure, go to an IMS, then it will go to a terminating IMS, then it will go to a 4G infrastructure and terminate the call. So in 5G also, we have a similar concept. Here, a lot more flexibility is offered in terms of, say, for example, using the same concept between a 5G core and IMS, you can talk to another 4G infrastructure and terminate a call on a 4G network. This is one particular use case. Other flexibilities are in a 5G ecosystem. What you see here as an IMS component can basically, using this N5 interface, basically help in creating barriers in the 5G ecosystem, right? Say what we call as some dedicated barriers. So what happens is that when a mobile connects to 5G, a default barrier is there on which through which you can initiate various other functionality. Say, for example, once a default barrier is established, you can dial a number, and that number will go to the IMS. Then IMS will create some additional dedicated barrier back in the 5G infrastructure, so that this mobile, other than having a default bearer, can also have a specific bearer on SIP signaling to facilitate this particular voice call, which will go through the 5G infrastructure and later through the IMS component to basically handle a voice call. So these are some of the deployment scenario. Hope this helps you to understand how typically a phone number dialed on your 5G phone is being terminated as a call through the 5G or, if required, a 4G infrastructure as well. So this is one scenario, right? Another deployment scenario in the 5G, this would be very interesting scenario. There is a network component called as N3IWF. So this N3IWF basically helps the entire 5G architecture to handle all non-3GPP interfaces. Say, for example, you are in your home. I'm just assuming a futuristic use case. You are now making a call. You are doing a WhatsApp call. You are outside on a 5G infrastructure. Then you walk into your home, and then assume that in the router, probably supplied by the same service provider, there is this component to handle communication to N3IWF of the 5G core. So basically, now when you enter your home, you get hooked to your router as well in the home. And the router there has a functionality. What is indicated, for a moment, assume this is you moved from outside to your home through this Wi-Fi access point. So this Wi-Fi access point will have interface to this N3IWF, through which all the IP packets behind the router can, in a secure manner, communicate to the backbone 5G core. Not only get connected, but also get authenticated. So these applications that are behind the Wi-Fi access point can also properly get authenticated at the 5G core. And then once these authentication are through, then you have a better path that is getting established from this Wi-Fi access point through N3IWF to the UPF. so that your WhatsApp call, when you moved into your Wi-Fi access point at house, can seamlessly communicate without any break, going through your Wi-Fi access point through the N3 IWF through the UPF. So you in the next 3 years or 5 years, you will see a lot of use cases or applications happening on this front where a seamless mobility, I would say, is established between your home Wi-Fi access point to the operator that you are connected to, uh, basically providing the interface and required integration. So, so this is basically to make sure that all the applications that are there in the traditional IP, pure IP infrastructure can also come and leverage the 5G core functionality, because 5G core as such provides a lot more functionality, such as it provides a better QoS handling. So this N3 IWF is a network function that facilitate this interoperation to happen. So this is another deployment scenario when it comes to 5G core. So here I illustrated a typical handover that is happening. So on the top you have assume a 5G RAN where it is connected to an RU, the radio unit. Then it is connected to a DU. Then it is connected to the control function on the user plane side and at the control side. So assume that a call from the UE was there initially connected through the first RAN, RU1, DU1, and CU1. And assume that the UE moved to closer proximity to RU2. Now, in this scenario, what happens is that since the proximity to RU2 is more there, the entire data path and control path establishment will shift from the RAN 1 to RAN 2 with proper handshake at a control level happening to the AMF, and then proper handshake happening at the user level with UPF. So this is how a mobility or a handover is can be facilitated between two RUs with the backbone 5G core, understanding where the signal is better and facilitating the transfer from one RAN to another RAN. So this is the handover deployment case in 5G. So any questions so far? So now after this, we will go to some typical use case deployment. So now that we understood some concepts, then we need to know how these are getting implemented in an end user scenario, right? So any questions so far, or else can we proceed?
Dr. Preeti, you had some questions, right?
Yeah.
Yeah, you can go ahead.
I just asked in like for private 5G, it is different from what currently going on. Like if you want to set up a 5G, small scale 5G setup, like as it is written for mines or for any lab, for example. So how much what all components will be involved and how much cost will be involved. So that's why I filled in Google form. Maybe it's out of, yeah.
Yeah. Probably we can get back on the cost, but typically to establish a private 5G or
Yeah, I mean from the lab perspective, not
Yeah.
from the
Lab,
yeah.
even a deployment, private 5G deployment in your educational institution.
Yes, yes.
So these are what you want. You would require a RAN, what you see on the left hand side. You would for sure require a core,
Yes.
and then you would, by core, I mean all the controller software that comes to configure the SIM. Then you can get a set of SIM configured, configure them on the controller, and then using any of the standard mobile or a CPE, using the SIM, you can try and connect to the RAN, and the core will authenticate and also facilitate in the data path communication. And so these two are mandatory. Of course, the firewall and other list of accessories that will come. I'll not go into big detail there. But what you see on the right, the edge cloud. If you want to set up a local edge cloud, that is optional. The why I say optional is even though that facilitate lot of leveraging lot of functionality that you can use as part of 5G. It is optional because you can still do a lot of net connectivity, browsing, etc., even without Edge Cloud. But Edge Cloud will typically be helpful because if you are going to leverage the latency and then local high availability, and then run some specific use cases in your private 5G network that you have established. So this is what you would want to set up a private 5G in your institution or in your lab, etc.
Okay, sir. I'll just in case if we'll need any query, we'll just get it.
Sure, sure.
I have one more question in the same slide.
Yes.
So you have this Niral OS IMS, right? So alternatively, if you look at in Open 5GS, what is the default bearer that is used in Open 5GS? Do you have any idea?
Default in the context, say for example, default bearer, right?
To browse internet, maybe.
Yeah, that default bearer by default, assume IMS is not there, right? Part of the Open 5G core will help you create the default bearer by which you'll have a QoS typically to support internet.
Do we really have to set up very similar to this Niral OS IMS also in the Open 5GS, like, or is it?
See, Open 5G core provides a basic core functionality. It will handle authentication. It will help you set up bearer with any of the RAN. Of course, you'll have to do some configuration. But if you want to make but even with that, you can do lot of calls that basically go through IP, right? But if you want to make you need to have an experience of dialing someone and then making a call, then for that an IMS is required.
Okay.
And see, you'd have heard about Camellio, right? So Camellio is an equivalent for Niral OS IMS to help you facilitate this end-to-end calls. So let's come to the use case with the assumption that this will help you understand the deployments in more detail. Say, for example, you take an open cache mine, right? So typically, you take coal mine, right? A typical use case of a coal mine is they would. I will take simple examples. They will have a lot of vehicles. You and in each of the vehicle there is a GPS tracker attached. And another use case you consider a drone flying all around, or a set of drones flying all around the mine, capturing a live video stream. Okay. So assume that this use cases need to be executed in a coal mine. So what you do is that, as the previous question, what do you require bare minimum to establish a private 5G network? So you would need a RAN that can basically communicate to all these devices. That is a GPS device, uh, assuming that it has some 5G capability to push GPS locations to a server, and 5G drone attached with the camera that can stream the video contents through a 5G SIM. So you require a RAN, so you will have to figure out an office space in that coal mine where you can set up this RAN that can communicate to these devices. Then you install a 5G core, basically, which can authenticate, where you can add the subscribers, etc. Then, depending upon your application, you assume that you also want to run video analytics of all the videos that are captured from the drone cameras. So then you also install an edge cloud. And then basically what you do is that assume that there are 10 vehicles, configure all the SIMs of all the 10 vehicles in the 5G core. Assume that you have about 5 drones flying around, and in each of the drones you have an camera and a 5G SIM. So configure all the 5G SIM in the controller. Then switch on your RAN and core, and then let their drone and the vehicles connect to the 5G RAN and to the core, and then enable an end-to-end communication using the edge cloud. So this is how you basically implement a private 5G network. And assume that tomorrow you want to add more equipment like geo-tracking, geofencing. Then you have some flying drones which capture some video, and then you want to apply some AR, VR processing on that and help the drone do further actions. So you can populate your edge cloud with more application. You can populate the network with more CPEs connecting, more IoT devices connecting. You can this way you can extend this functionality to more use cases. So this is one example. And the second example is nowadays you can see lot of ports throughout the world are showing a lot of eagerness, and then they are putting up a lot of pilot projects to see how at the port private 5G can be established. So typically we can have a 5G RAN and 5G core edge cloud connected in the data center or the local data center in a port. Then to all the ships, we can give a CPE so that all the applications that are there in the ship, as soon when they approach near a port, they can get immediate connectivity to the 5G backbone. And then seamlessly data from the ship can be transferred into the backend cloud for various server processing. So this is how typically in a port the use cases are getting deployed. And again, all ports have drones, video surveillance. Then you can have equipment that provides asset tracking. Then you have the entire transactions at the port that can be handled through mobile application connected on 5G. So various use cases are possible where. So typically, any use case or any environment where multiple Wi-Fi access points were used to see 5 years back, 10 years back, in all these ports or all these coal mines, what was used was multiple Wi-Fi access points. At least they could do the work, but they had a lot of difficulties in cables running around and its own related problems of cables running around in the premises. All of these can be seamlessly handled with the deployment of a private 5G in these scenarios. So this is a use case where in a big agriculture farms. So there are a lot of use cases around the world. Recently, a proposal is also floating on a pan-India level of establishing 5G intelligent village, right? Of course, 5G intelligent village is much more than agriculture. How you can digitally connect a remote village and then facilitate transformation in the village by quick access of information to from the external world into the village. So typically, here again, the use cases can be drones, IoT devices for soil, water monitoring. Then it can be in a 5G intelligent village, it can cover schools, it can cover hospitals in the rural areas, it can help in the remote diagnosis. So, lot such use cases are feasible. And of course, if spectrums are available, setting up a private 5G in today's world is less than a month's effort because we have a very good equipment ecosystem. We have a very good technical deployment expertise with a lot of companies. So this can be quickly made possible. So these are the use case view of 5G. How 10 years back, multiple access points were inefficiently solving a problem, to how 5G can help quickly help people get onto their work, covering a wider space, be port, coal mine, or agriculture, anywhere. So this is what 5G is enabling today to achieve end-to-end use cases to happen more efficiently. So I think we have another 10 more minutes. We can take up some questions.
So we actually spoke about Niral OS in this entire session, right? So do we have any other alternatives or like competitors for this? Like, is there anything in the market at present?
Yeah, there are a lot of people, but of course, Niral has an edge in the market because of more number of deployments. There are solutions available from HP. There are solutions available from other players. And Niral, we have integrated our core and edge platform to about 20 different RAN G-Node B vendors. And I'm sure in that about 5, 6 are completely indigenous products, say like Leica to Resonus, to Vividian, to name a few. So the entire ecosystem in India for an indigenous product is quite building up well. So a carrier for many of you who are uh, from joining this program from educational institution, there is a wide variety of application that will happen. And in 5G advanced and 6G, there will be a big focus on couple of things. On a very advanced versions of edge cloud will emerge. A lot of quantum computing integration will find ways. Of course, there will be a lot of improvements in the 5G core and RAN architectures on the modulation front, um, etc. And of course, the virtualization infrastructure will be leveraged much more than what is done now. So all these facets of technology will start getting integrated more and more and improving more and more.
Got it, sir. Thank you so much. Sir, what will be the maybe just like highlighted or one or two selling points that Niral stands out from other products?
So as I told you, right, if you take India, for example, there are very few you can count with one hand, right, the number of private 5G deployments, and we already have a couple of deployments. So our biggest strength is the number of deployments so far. So because, see, deployments brings with it a lot of learning. And the number two aspect is your product gets stabilized. See, we have integrated with about 20 RAN and G-Node B equipment. So each of the integration brings with it a set of learning and makes your product more robust, both architecturally and also in handling capacity. So those are the some of the good features from our side. And of course, we are a very technologically evolving company. Our focus is there, or I would say we have started focusing big way on AI, how AI can be integrated with edge cloud well. So those are some of the key USP selling point what I can highlight.
Got it, sir. Thank you so much. So just one more question. So what are the sensing technologies or sensors that are used part of the infrastructure, if anything that you can mention, and maybe the role of it, like what is the application for that sensing?
What technology sell?
Sensors or sensing technologies, part of the edge cloud or edge computings.
See, a lot of these military installations, they have a lot of requirement on various IoTs, from image recognition to sort of motion recognition to various scenario recognition like smoke detection from a video, etc. So we anticipate a lot of this ecosystem, and coupled with edge cloud becoming more and more AI driven, we see a lot of potential in this space. Then Other aspect is, of course, there are a lot of IoT devices that are there, and using the NB-IoT features or the IoTs interfacing to CPEs, you will see a lot of them. See, what I would say, right, in the next 3-4 years, if the spectrums are made more available, in India, you might have 100 to 200 private 5G installations. So you will see a good avenue in all these places. Lot of IoT devices, right from image to other IoT device integration, and the analytics that will get evolved around it will all quite sure on cards, I would say, to happen.
Thank you, sir. So one last question, sorry for taking others' time also. So what are the security standards that we are expecting part of the deployment? So, I mean, like 5G technology itself has some of the security standards included. So, but in terms of deployment, what are we? I mean, what are we expecting to be part of the deployment stage?
Okay. So let me talk from two aspects. One is if you here you see a lot of network functions, right, as part of 5G core. So to this through this feature through this network function such as NEF, a lot of third-party applications can also communicate. Okay. So one security aspect that is evolving here is these all network functions communicate using HTTP. And when we say HTTP, a fair amount of TLS authentication can be enabled across these network functions. So when you allow various third party to integrate with NEF network function, then it becomes all the more important that there is some level of security on every communication level happens. So that is one that is happening. Another aspect is say when you drive the whole of these deployments through a virtualization infrastructure, then typically how it happens is that there might be, as part of this virtualization, there will be other non 5G components can also find a place, right? So so the communication from the third party in terms of providing session level and more dynamic access control, say like starting from Java Web Token to all the dynamically negotiated tokens that can be alive for a particular session or for a particular duration. So those are other security aspects that are evolving from a virtualization point of view. Then, of course, there are at a protocol level communication between RAN, mobile, the required keys that facilitate facilitate ciphering and other functionality. That is, of course, evolving through the 3GPP standard. So these are all some of the security related aspects that are evolving in the entire ecosystem. Mainly on the 5G core, the virtualization, edge cloud.
Got it, sir. Thank you so much, sir. Actually, this gave me a good structure to deep dive. Thanks a lot, sir.
So in the next session, we will go So the next session is on, I'll give you a very short couple of minute overview heads up. So what do you see on the different network function, which will do a little bit deep dive, and we will focus on communication between them. Then apart from that, we will little bit deep dive into the virtualization, orchestration, edge cloud, that space. And we will also do some level of, we'll show you some Wireshark logs also in how communication with an external radio access network or a UE to 5G core happens. So these are the some of the subsystem level understanding we will develop in the next session.
Sir, I have a small question actually.
Yeah, please.
Please go ahead.
Actually, this is regarding, the 5G. I heard somewhere that 5G technology, the 5G band is also used in when you talk about aircraft, the fighting aircraft. So these 5G technology is currently not used in fighting aircraft because it has a collision with some of the sensors. I mean, like radar band, whichever it is. So uh, is military sector still restricted to use 5G technology at this moment, sir?
Okay, so to answer from my capacity on that, see, we saw the radio access network, right? Always they operate on N78 band or N28 band in India. So the crux of the matter is which of these bands can give you a big bandwidth. Say, like for a reasonable operation of 5G, you should have a bandwidth of 100 megahertz so that you can achieve the data rate of 1 GB and above, right? So ideally, this is how it goes. Like wherever, in whichever frequency band this bandwidth is available, always there will be competition between military and non-military. And of course, there are policy framers who are best suited to take a decision on that, considering a lot of viewpoints from the operators, from the military, etc. So technically, 5G can operate at multiple bands, but the other variants that come into play that is beyond technology normally is also considered while making a decision here.
Very much thank you, sir. Thank you so much. I have a couple of questions, but I would like to ask it during the workshop or something.
Yeah, I think Ruth has also provided a channel through Google Form to ask questions. You can also ask there, and maybe because there is only a set of questions we can handle in these 2 hours, right?
Yes.
So you can ask there, and we will try and see. We will consolidate those questions and then answer either now or maybe when we meet for a face-to-face session.
Yes, sir. Yes. Better. So that would be a great idea.
Okay, Ruth. So can we conclude now?
Yes. Yeah, sure. So as we wrap up this today's session, it's incredible to see how communication has evolved, right? From basic telegraph systems and then, moving on to landline phones to mobile networks, LTE, and now revolutionary era of 5G, 6G. Just transformation has redefined how we connect and interact with the world around us.